everybody. My name is Massimo Benini. I'm from CSCS. I work in the System Integration Group, and today I'm going to talk about how we manage GPUs by SLURM. Okay, this is the agenda. Because I don't know the background of everybody, so I will have a little general introduction about SLURM. I will show you a little overview about SLURM with our machine at CSCS, how it is configured. And then I will talk about this special plugin that we use for managing the GPUs. And then I will, is there a laser? No? Oh. Anyway.
This guy.
Okay. I will talk about this tool for reporting data and statistics about the utilization of the GPUs. So, what is SLURM? SLURM is an open source cluster management and job scheduler for Linux cluster. Mainly are three key functions. It allocates in an exclusive and or non-exclusive way nodes or socket or CPUs to the jobs. It comes with a framework for starting job, executing and monitoring jobs. And he has all the logic for arbitrate contention because it works with queues. So it manages all the priorities and the queues about the jobs. So this is an overview about the architecture in a generic Linux cluster. So we have the main brain, which is the SLURM control D, which is always run on a service node. It's better if it comes with a backup. So on every compute nodes run a SLURM daemon. SLURM daemon basically it works like a remote shell. So it waits for job, then you get the job, execute the job, and then you keep on waiting until somebody tells you something. Then we have an optional SLURM database daemon. This component is used for storing information about accounting, and it can be used for limit the utilization to introduce a limitation for users, group, and most important, it can be generic for all intercluster, generic for all the cluster of your company. So on the left side, we have all the user commands that we need for using it. So as control, it's the most used command for the administration. Basically, it's the Swiss knife of SLURM. With SQ, we can see the status of the queues. SECT talks directly with the SLURM database, so we can query the database through this command. SRun, it's the command for executing jobs, and then scancel plus we have other commands. This slide is because our main systems are craze, and there are some differences on. I'm sorry, you can read very well here. There are a lot of differences on the craze. So the SLURM CTLD used to run on the front end, so on a service node. But the main difference is the SLURM daemon is not running on every compute nodes, only on other front-end nodes. This is because Craze has his own scheduler, which is ALPS. It's an application scheduler, and we put it's not completely. It's dependent on other scheduler. So that's why we build SLURM. We put SLURM on the top of it, and Cray provides this interface called Basil, which is XML basic application scheduler interface layer. It's an XML interface, so SLURM will constantly talk with apps through this interface. There are other differences. For instance, at the moment, you cannot allocate a single core, but on the Craze you have to allocate the whole node. But this is gonna change in the future, because there are plans of create a native SLURM on the Craze. Plugin. SLURM is built with the plugins, a lot of plugins. This makes the code more flexible. It's mainly a C code. Everything is written in C. With all of these plugins, you can decide of use it or not using. They provide interfaces for developer to modify them, changing or add the logic that you want. So for instance, we have the accounting storage. This is the plugin that make you use the SLURM database and store information about accounting of your job. The generic resources plugin, which I'm going to talk about it later, because it's the one that we use for managing the GPUs. The job submit plugin is a plugin that can make you do some checks or execution before the job submit. For instance, if you want to check if the user is allowed to run or not, or any kind of calculation before the job submission. The priority, this plugin makes you use a priority mechanism for managing different queues or priority inside the queues, and so on. The scheduler is with this plugin you can choose the kind of scheduler, backfill, linear, and or other kind of scheduler. You can decide the logic of your scheduler. Task affinity is used for binding jobs to specific CPU or processors. And node selection, it's another kind of, it permits you to choose the node, for instance. On the Cray, there's only one possibility, but you can select a linear node selection, and so on. This table, I hope it's updated, but should be. It's more or less an overview about all the machine. We have more machine, but this is the one that I'm used to work with. But this is to show you that it's a very heterogeneous environment at CSCS. So we have Craze, not Craze, Craze with different architectures, and we have different kind of CPU. For instance, we have this visualization cluster which has nodes with different kind of GPUs on it. So in one node you have a kind of GPU, in another one, and so on. So this is the more emblematic type. So what is generic resource plugin. It's a plugin which has the logic, the mechanism of how to set up the GPU for SLURM. Because if you don't use this plugin, SLURM only knows about socket, cores, threads, nodes. But with this plugin, you can add every kind of generic resources. We use this for generic resources like GPUs. It's pretty simple and straightforward to use it. To enable the GPU support, you just need to modify the slurm.conf, which is the main configuration file for SLURM, plus add grace.conf file on every node that has a GPU. So here's a snippet of Eiger, the one with a lot of different GPUs. On the slurm.conf file, you have to specify a grace type. In this case, we name it GPU. Very simple, straightforward. Can be mic or can be whatever you want. After, while you are specifying the nodes, you have to specify the parameter grace with the grace time column a counter. So this means that this node has a GPU, only one GPU. If you want to give the user an easy way to allocate the nodes, then you can label the node with this parameter, which is a feature. So you can give a more human readability to this node. So, but I will show you later how can you use this label to call exactly these nodes. And that's it. So the other part of configuration is the grace.conf file. Must be present on every compute nodes with the GPU. And for instance, on Dynit, we have nodes, all the nodes have the same GPU, so we put this file on a shared directory because it's the same for every node. This file, it's very simple. You have to write the same grace type on the UROD, on the slurm.conf file. Then you have to specify the device of the GPU. This is on the craze. It's better if you specify the dev null because you're not running the slurm daemon on the compute node because you're running on the front end. Plus an optional. Here is not reported because it's one, but if you have more than one GPUs, you need to put a counter. So another parameter which is count 2, 3. And optionally, there is another parameter called CPUs. And this is if you want to tie some processor, some CPU to the GPU, but not all the CPU. So in this case, the default is all the CPUs can use the GPU. Some usage example. On the first line, we are just asking one node. We want a generic resource, which is one GPU. And this is the way we specify the label feature that is written on the slurm.conf. So with the option constraint. So here we're asking for one GPU of this kind. In the second example, we can use a OR. So the scheduler will give us or this kind of GPU or this kind. In the third example, we're asking for two GPUs. Either can be both this kind or this kind. So it's pretty straightforward, even the allocation of these GPU and GPUs. Another kind of GRES, generic resources, is the amount of memory. The amount of memory, it's exactly like another generic resources. So we have to specify another GRES type, GPU memory. And on the node definition, the GPU memory plus a counter. So this means that all of these nodes will have this amount of memory, which is in megabyte, if I remember correctly. And on the gres.com file, the counter, because by default it's 1. In this case, it's more than 1, so it's going to be this much. And that's it. GPU utilization account. Because of this new feature, the GRES, we wanted to be able to measure how much GRES were allocated and requested for every job. So the SLURM code has been modified, and even the account storage plugin. So now on the SLURM database, we have 3 more columns to keep track of the generic resources requested for every job and the generic resource effectively allocated. There's a third column, which is for now it's only a placeholder. This is going to be one of our next tasks, because we want to see how much generic resources has been effectively used. But there are no way at the moment. So this is because we don't know with SLURM where to take the data from. And this is going to be one of the future work. RUR. But on the CRACE, we have this generic utilization report tool. What is it? It's a tool for gathering statistics on how system resources are being used by the applications. So RUR look at the compute nodes. It's like if it's taking a picture before a job application run and right after. So it can stage all the data. At the moment, it's an extensible tool. So at the moment, we collect data about accounting, energy, and GPU accounting. So this is the way we can retrieve the data for the CRACE about effectively how much GPU the job has used. This is the schema. So we have a first stage called data staging. Then when all the jobs or the job steps run, we have a post-processing where statistics and sums and other calculations are done. Then we have an output phase where, depending on which plugins you enable or not, you write the data on the log file or maybe on another SQL database. And this is pretty much the schema. On our new big machine, Pitts Giant, it's enabled by default. So all the users, after they run a job, they can see on their, by default, on their home directory, a file called rur.thejobid. in this file, you can have all of these statistics retrieved by the RUR. And these come handy when you want to know how much you've used your GPUs or energy or other. And that's pretty much it.